Okay, so how dangerous is it to do a sort of fairly common job on an EV, but to not really fully understand what you're doing? And are there safety systems in place that will protect you, or how easy is it to come into direct contact with the high voltage system in a dangerous way? Okay, so this kind of scenario is quite a common scenario. Let's say this air conditioning compressor needs replacing on this Zoe, and it's just down there. It's not that difficult to access. It is a high voltage compressor, and let's say that we either are not high voltage trained, we're not aware of the safety precautions we need to take, so we're just going to plow on and do it, or maybe we're not following our training and we've not done it correctly. But are there safety systems in place, or is it going to get exciting fairly quickly? Well, yes, it might be the latter. We shall see later. The first thing I should say is I am EV trained. Please do not attempt to replicate this. I mean, firstly, don't do anything on your vehicle which you're not trained or experienced enough to do. But in this scenario, I'm going to do something which goes against the training, and we're going to see whether it's dangerous or not. What I'm actually going to do is pause the video. I'm going to do a high voltage shutdown on this vehicle and kind of set it up rather than just ploughing on. But we're going to kind of see what happens, but in a slightly more safe scenario. But yes, I should really just emphasize that EVs have high voltage DC and don't have like the circuit breakers that you've got at home in your consumer unit. So at home, if you change a light switch or a plug socket or something like that, and you don't isolate the circuit correctly, so let's say it's like an upstairs downstairs light switch, and you don't realize that it's powered from upstairs and downstairs lighting circuits, so one of them's turned off and one of them's not. If you touch one of those wires or touch them together, the circuit breaker will trip, and they are designed to trip that quickly that it won't kill you, basically. So those safeties are all built in. The high voltage system in an EV, well, the main fuse on this car is about 250 amps. We're talking about 375 volts. If we're looking at the air conditioning compressor, that's got 40 amp fuses, sort of downstream of that big fuse. There's a lot of power here. And so if you do something and it goes wrong, it's going to kill you, and it's going to hurt all the time you're dying, okay? The most dangerous thing is to have an electric shock from one hand to the other. So let's say you're touching the car body and touching the pins or something like that. If there's something that causes the electricity to run through your chest, that is the most dangerous scenario, because at the kind of voltages in this EV, it can stop your heart, okay? If you get to really high voltages, it can fry your insides. But this is certainly enough to stop your heart, okay? So let's talk a little bit about the architecture, and then we'll see what happens when we sort of plow on and yeah, see what happens in terms of whether we can get a dangerous voltage. So first, a little bit about high voltage things and how they work. There are some safety systems. I mean, someone may start doing this without being aware of the safety systems at all, but even a little bit of knowledge is a dangerous thing. So I've got a compressor here. This is the connector from the compressor. So it's got the two main pins inside. You can see those little spade connectors, one on either side. And then in the middle, there's a couple more connectors there. And then if we look in the sort of the kind of cable that would plug into this, you've got the, if that will focus, so you've got these, you got those two there, so that's your main power pins. And then you can see down in the middle there, some sort of goldy, brassy colour pins. And that's what's called an interlock connector. So the car has visibility of all these connectors for safety reasons. So when this is plugged in, as well as the two bigger pins around the outside making contact, obviously provide the power, the ones in the middle tell the car whether the plug is in place or not. So if we look at this, we've got the two big wires here. So we've got our positive and our negative. And then we've got these little ones here. So these tiny little wires. So there we go. So this is so that the compressor knows whether that orange cable is plugged in or not, so it knows whether there's a dangerous situation. Okay, so okay, great. So the car's going to know whether it's unplugged or not. So let's just have a look at that in practice. I've locked the car with the key. There we go. So, right, so if we look on this diagnostic machine, you can see here we've got interlocks. So we've got air conditioning compressor interlock closed, that's one we're looking at. And there are other interlocks. So the car, these are all places where there are high voltage connectors or safety plugs, that kind of thing. And the car is able to monitor whether they are connected or not. Okay. So the car will know when it's unplugged. So surely it's going to shut down or whatever. And this is really the scenario where a little knowledge is almost more dangerous than no knowledge at all. Because if we think, oh, it's got an interlock on it, the car's going to know whether it's unplugged, so the car will just make it safe, shut down or whatever. Well, let's see what happens. Okay, right, I'm just going to do a high voltage shutdown on this car, and I'm going to get some connectors off, put the meter in, and then we'll see what happens. It's worth explaining one interesting quirk with the Zoes that make this even more dangerous. So the Zoe, we haven't started this car, it's not in ready mode, but if we look at the voltage of the 12-volt battery, we got 13.4 volts. Okay, so and just confirm on the dash, this car is not in ready mode, it's not ready to drive. Okay, so a quirk of a Zoe is that as soon as you unlock the car and open the door, the high voltage system comes alive. It starts, the contactors are closed, the DC-DC converter's on, and that battery is being charged. So people may not be aware of different quirks of different vehicles, but that's something that's potentially quite dangerous. Because if we're not aware of that and we start pulling connectors off, there is a dangerous voltage there. Even if the car was to shut down the high voltage system, there's capacitors built in, and we can still get a dangerous electric shock. Okay, so that's an interesting quirk. Bear that in mind. I'm just going to shut this vehicle down and get the connector off, and then we'll see what happens. All right, catch you in a bit. Cheers. Okay, so I've done a high voltage shutdown on this vehicle, and then taken off the connector, put my meter in it, and then done a high voltage reinitialization. Okay, so this car is not running, it's not in ready mode, but it is awake. So I've unlocked it and opened the door and checked the diagnostic machine is connected. If we have a look at this, we have got 386 volts on this connector, which is the one from the air conditioning compressor. Okay, so the car is not running, it's not in ready mode, it's just awake. So even though it's got one of these sense connectors, an interlock connector, there is still high voltage on that connector. So let's have a look at the diagnostic machine, because it should know that that's disconnected, right? So if we look here, now we've got air conditioning compressor interlock opened. So the car is fully aware that that connector is disconnected, but it's still powered up the high voltage system. Okay, because as we said earlier, a Zoe, when you unlock the door and open it, it turns on the high voltage system, closes the contactors, which is the big relays in the battery pack, and starts charging the 12-volt battery. So if we were not aware of the safety implications and just thought, or we'd even heard about interlocks and said, oh, the car knows if it's disconnected, it'll shut down or whatever, we could very easily end up in a dangerous situation. And even if you think, oh, well, the car's locked, you know, I'm not going to open the door or anything like that, you can have charging timers that can wake the car up. You can have preheat timers. EVs can wake themselves up to charge the 12-volt battery if they see the 12-volt battery getting low. So it is relatively easy to end up in a very dangerous situation if you don't know how to do a high voltage lockout, high voltage shutdown first of all on the EV, high voltage lockout. So the high voltage shutdown is where you would remove any safety connectors or fuses, that kind of thing. It's usually a couple of stages. I kind of want to be careful with what I say because I don't want anyone to try this. I just want to say that those processes and those safety things are there for a reason. And if you're not suitably trained or experienced, you could have shadowed someone and they could have explained it to you. And as long as that's happy with the place of work or whatever you're doing, then fine. But suitable training or experience is extremely careful. So yeah, to shut down a vehicle, you normally do a high voltage shutdown. you would do a high voltage lockout so that nobody can undo that shutdown. If you pop to the toilet, make a cup of tea, and someone doesn't realise, they think the vehicle's done, and then they reinitialise the high voltage system, for example. So there's lockout kits or other methods of preventing that vehicle from being reinitialised without you knowing it. And also there is high voltage verification, where you would double check that something is safe before you proceed, because there's still capacitors, things can still be charged up, that kind of thing. So we've got a situation where effectively we've just ploughed ahead. Maybe we're not aware, we just think it's going to be fine, it's just an AC compressor. We've pulled off the connector, and that connector has high voltage on it. The car is actually aware that that connector has been taken off, but has chosen to start the high voltage system. There's no warnings on the dash, even though we've got a high voltage connector hanging off. So why does it do that? Why has the car chosen to do that? Now you can sort of see the logic of the people, when the engineers and designers, when they're looking at the car. So the AC compressor is reporting that it's open, but the car's ignoring it. Why is that? Well, I believe that they're trying to avoid a broken AC compressor bricking a car. And this happens across multiple vehicles. This is not just a Zoe thing, okay? Multiple vehicles will ignore interlocks for certain components. So when they were designing the car, they were thinking, oh, if the AC compressor breaks and is not able to report the status of that connector, we don't want that bricking the car just because the AC compressor is faulty. Because if you get a faulty batch of AC compressors or heaters or any other high voltage component that could get into this situation, it's obviously going to be something like an accessory, because if it's, you know, like a drive inverter or something sort of serious, you're not going to have to drive the car. But a batch of faulty AC compressors could brick cars if the car would only start if it received that signal from the compressor to say that that was connected. So they've made a design decision here, that even with an open interlock, with a connector disconnected, the car will still start, okay, which is potentially extremely dangerous if you're not aware of how to shut down the high voltage system on this car. Now, okay, so the car doesn't mind that it's disconnected. So what you can actually do is you can start and drive this car. So I can put it in, let's turn it off. Yeah, we can move the car. Obviously I don't want to move it too much because I've got a meter sitting there, but this is in ready mode, just to confirm. This is not some kind of party trick. Right, the car's running, engine running, switch on. It started raining, hopefully, so I moved into the workshop. But this is still sat here with a connector off and 386 volts. So yeah, this is really just to highlight that not knowing the correct procedure can be extremely dangerous. Presuming that the car will shut it down can be extremely dangerous, and not understanding the architecture of the vehicle can be extremely dangerous, because, as we said, these Zoes, even when they're not running, not in ready mode, will start the high voltage system. So, you know, we could park this car, think, oh, it's not in ready mode, it's switched off, the dash is awake, but the car's not in ready mode, disconnect that connector and get electrocuted. So yeah, I just kind of wanted to show really that it can be dangerous if you're not aware of the correct procedure. Even doing, I have to point out, doing a high voltage shutdown on a Zoe involves getting very close to live high voltage, and the shutdown procedure on a Zoe should be done in a particular way, but there's also the lockout and the verification of that high voltage system as well. So yeah, stay safe. If you're not trained or experienced, please just don't do it, okay? And whether you're at home or in a garage situation, and just, yeah, take care, because if you get this wrong, and that is making me nervous, I'm going to take that away in a second. If you get this wrong, it's gonna kill you, okay? So yeah, I hope that's interesting. If there's other questions, let me know. Big shout out to my members. We've had some really interesting member discussions and sort of requests for videos and stuff like that. But yeah, just stay safe and just be aware that things can go wrong very quickly. Yeah, it's just an AC compressor. I'm going to switch this guy off. because it's making me nervous. Yeah, it might just be an AC compressor, but yeah, you just need to be really confident and careful and take care with what you're doing, okay? All right, and if at all unsure, just don't do it, okay? All right, take care. Cheers.